Hi, I'm Britanie. So in this video, I will explain about the potential energy. So here is the points of what we're going to discuss today. The first point of our discussion is the theory. For the second one, we'll have a practical simulation of how the theory works. And for the last but not least, we'll have the questions example. Let's now move on to the basic information. In physics, potential energy is the energy held by an object because of its position. It can also be stresses within itself, its electric charge, or other factors. Potential energy is commonly symbolized as PE, U, or V. Some people also use capital E and small letter P as the symbol. And since potential energy is an energy, the SI unit is joule. Potential energy also have various forms such as gravitational or gravitational potential energy is the energy stored in an object relative to its position and related to gravitational forces. Next, we have the chemical potential energy is the energy stored in the chemical bonds of a substance. And last, we have the elastic potential energy. This is the energy stored as a result of applying a force to deform an elastic object, such as springs. As you can see here, we got a lot to discuss. So that's why I will divide this video into 3 parts. Let's first start with the gravitational potential energy. Theory. As you expected, gravitational potential energy is associated with the gravitational field. It is basically the energy stored in an object when they are in the heat. Potential energy can also be converted into the kinetic energy we discussed a few days ago. This happens when the object has released the stored energy. Then by those explanation, we'll get mgh as the gravitational potential energy's formula. EP is the potential energy with the unit joule. M is the mass with the unit kilogram. G as the gravitational acceleration with the unit m/s square. And H stands for heat with the unit meter. So how it works? So let's imagine there's a table up above the ground. The table have stored a potential energy. Now what if we have an object? This book I put on the table also have a potential energy. Then the potential energy will finally be released to kinetic energy when I let it fall to the ground. Question examples. A coconut is on its tree at height of 6 meters from the ground. If the coconut is 2 kg in mass, what is the potential energy of the coconut with the gravitational acceleration of 9.8 meters per second square? So first we know that the coconut is at the height of 6 meters from the ground. With that information, we can write that the height is 6 meters. Then it also says that the coconut is 2 kg in mass. Then we can write the mass is 2 kg. Then the last information we know is that the gravitational acceleration is 9.8 meters/second square. In this question, we are required to find the potential energy of the coconut. From what we have known above, we got all the information we needed to count the potential energy of the coconut. The M is 2 kg, the G is 9.8, and the height is 6 meters. Now with this multiplication, we can count the potential energy, which is 117.6 joule. Example 2. An object with 5 kg in mass is lifted from the ground to a place 5 meters high above the ground. Determine the potential energy of the object to the ground and a place 2.5 meters above the ground. So let's see what we know. The object is 5 kg in mass, so we can write it. Then the object is 5 meters high above the ground. There is no gravitational acceleration in the question, so we can write it 10. The question asks for 2 answers, the potential energy of the object to the ground and a place 2.5 meters above the ground, so we can write it energy potential 1 and energy potential 2. As usual, EP has mgh as the formula. So EP1 have mgh1 as the formula. Height 1 comes from the first height we know. As it was explained before, the object with 5 kg in mass is lifted from the ground to a place 5 meters high above the ground. So it's the first height. Then we can use all information we got to find the EP1, which is 250 joule. For the EP2, we have mgh2. H2 comes from the information of the last sentence, which is 2.5 meter. So we can simulate that the object might have be lowered down 2.5 meter above the ground. So this is the H2. Then it's an easy work now. We can just write all information we got to count the EP2, which is 125 joule. And we're done with the EP1 as 250 joule and the EP2 as 125 joule. Thanks for watching. Any question? You can leave it on the comment below. Bye bye.